Assalamu alaikum. Here we are again with another important topic in laparoscopy or any other surgery. That is, we'll be discussing today the energy sources in laparoscopy. So let's begin with the talk here. The energy sources are the sources or the instruments that are used to cut the tissue, to coagulate the tissue, and so on. So these can be categorized into a monopolar diathermy and bipolar diathermy, ligasure and harmonic. The monopolar diathermy is a diathermy which has a console, and it has a high frequency cord, and it has got an entry point. It has got an earthing plate which is attached to the patient's body. So there is an entry point of the electrical current into the body, and then there is an exit point which is the earth plate which is attached to the patient's body. So the in between the current is used to coagulate or cut the tissue in the body. The high frequency cord, it is called the high frequency cord because if the frequency of this cord is low, as we all know that there is electrical activity in the muscle, the skeletal muscle. So if and every muscle is contracted by an action potential. So once the action potential is generated, there is movement of actin and myosin fibers over each other, which leads to contraction of the muscle. So after completion of this cycle, physiologically, there is a refractory period in which if there is even an electrical stimulation, the action potential will not be generated. So the high frequency cord is actually the cord which produces energy or electricity at such a high frequency that action potential is not generated in the muscle. So if that cord is not of good quality, or if of low frequency, then you can see that the patient postoperatively feels to be really exhausted, and there are generalized body aches and pains. And then you can know that yes, of course, this monopolar diathermy may be having a low frequency or a poor quality cord. So there are certain pointer instruments as well, as can be seen here. So these are the pointer instruments. There is a standard hook with 8 millimeter exposure, same kind of hook with the 5 millimeter exposure, or a spatula, or the end of that pointer instrument may be anything that you want to use. That can be used with a scissor, with a grasping forceps, with a dissecting forceps like Maryland forceps. Anything can be connected to a bipolar or monopolar diathermy, and that can be used. Monopolar diathermy is really very cheap to use. It is available everywhere. For laparoscopy, you'll have to have just the cord which is used for laparoscopic procedures. Otherwise, it is readily available and relatively cheap as well. However, it is not without dangers. So dangers of monopolar diathermy are that there is heating and there is diffusion of electrical current, which can lead to injury in different organs. Heating can this is called thermal injury. You are using the hook here, but the heat or the thermal energy is going to the nearby tissue as well. So that can lead to thermal injuries, and diffusion of electric current can also lead, like for example, I would say if you are mobilizing the duodenum while performing right-sided nephrectomy, you have to be really careful, and the diathermy has to be really away from the wall of the duodenum. Otherwise, it is going to get thermal injury. which is going to be evident 48 to 72 hours after the surgery and is going to be a disaster. What are the mechanisms of monopolar diathermy injury? These are can be divided into direct coupling, insulation failure, and capacitive coupling. Talking about the direct coupling, one can see here that you can see that there is mm, a telescope in this diagram, and there is an instrument which is metallic instrument, and that metallic instrument is actually grabbing that tissue or touching a tissue, in this case the gut, and this your instrument, which may be a scissor or it may be a dissector or it may be a hook or a spatula, it is indirectly touching that instrument, and that instrument is conducting the electricity, and that can lead to thermal. This is called direct coupling. Then is the second type of injury, which is called the insulation failure. Here you can see that, let's say we are using a diathermy, a scissor. In every reusable instrument, you can see that it consists of an outer insulation sheath and an inner working element and a handle. These are three basic components of a reusable laparoscopic hand instrument. So if you are using a monopolar diathermy, in any case, while that is a scissor or hook or spatula or any instrument, if you intend to use a monopolar diathermy, you must first check the insulation sheath of that instrument before starting that procedure, because there are minor small leaks or small holes in that sheet. With the passage of time, there is wear and tear, and a small hole in that insulation sheet can lead to this type of injury. You are not touching the tissue or the gut, but you are working away from the gut somewhere else. But you can see here that the sheet where there is a hole or a breach in the insulation is indirectly affecting the bowel or any other organ for that matter. It may be an artery or a vein. So this is called insulation failure. Okay, then comes the capacitive injury. Capacitive injury happens, you can see that it occurs whenever a non-conductor separates two conductors, creating an electrostatic field. So this leads to injury. Here, according to the instrument composition and placement, a current in one conductor can induce a current in the second conductor, and this can lead to injury to the abdominal wall or the gut, etc. Then here is the case where in the first instance it was the metallic cannula. So your instrument, the monopolar diathermy, which is touching the cannula, can lead to passage of current through that cannula and can lead to burns to the abdominal wall or the bowel and other organ injuries. Now in the second instance, you can see that there is a plastic cannula, but inside the plastic cannula there is a metallic reducer, and that can lead to activation of that metallic reducer and can turn it to into a capacitor. Actually, capacitor is a metallic instrument which can store current. So current is stored in that, and that energy then leads to injury. It is a worst case scenario. And here you can see that if you are using a metallic cannula, so an insulated instrument in that cannula can really lead to injury of the organs. Then comes the bipolar diathermy. Of course, the bipolar diathermy is actually the same as the monopolar diathermy. In it, what happens is that there is a console, there is a cord, and there is a pointer instrument, and there is an entry point and there is an exit point. But the entry point of the instrument through one jaw, and the exit point is through another jaw. So the current does not have to flow through the body to go to the console. So this is basically the mechanism of the bipolar diathermy. Here in the diagram, you can see both the monopolar and the bipolar diathermy. In the monopolar, current is coming from the console. It is getting entry into the body, and then it is passing through the human tissue for a certain desired action, and then from the body it is passing again through an earth plate towards the console. However, in the bipolar diathermy, here you can see that there is no earth plate required, and the current does not have to move through the whole body. So the advantages of bipolar over the monopolar are that the current is not passing through the body, so the muscle does not have to contract in the process, and thus the patient is not exhausted by the end of the procedure. And the other important thing is that the diathermy burns. In certain cases, if the earth plate is not applied properly to the patient's body, the patient can have severe devastating burns to the skin, requiring plastic surgery procedures. In bipolar diathermy, it is not usually required. However, in bipolar diathermy, you cannot use an instrument which is for the cutting. And another difference is that bipolar would usually work better if you instill the tissue with the normal saline. If it is not working, I think you should instill or spray some normal saline over it, and then you can see that bipolar is working perfectly. Okay, again, almost the same thing. It is safer, the bipolar diathermy, as the current does not pass through the patient but returns to the generator, where the receiving pole after passage through the grasp tissue. Here again, you can see the monopolar and the bipolar. It is almost the same, what we have explained previously. Okay, effect on the tissue. Here in this, you can see that with rising degrees of temperature, you can achieve different desirable effects. Here you can see that 30 to 60 degree centigrade, there is cell destruction. Then you can achieve coagulation from 60 to 65 degree. Then from 65 to 90, there is desiccation, and then vaporization, and then carbonization at 120 degrees centigrade. Same can be seen on the left hand side on the effects in the figure. However, the effect of diathermy, whether that is monopolar or a bipolar, it depends upon the type of tissue, the amplitude which you have preset in the console, whether it is you have a preset of 30, 35, 50, 60 or more. And it also depends on the time of the application, for how long you are applying it. So and so these are the factors on which you can see that what kind of desirable effects you want to achieve, whether you just want to fulgurate that area, whether you want to coagulate the area, whether you want to cut the area along with coagulation. So this is how it works. Okay, so these are okay. So one of the most important thing that I want to mention here is that the most common mistake when a diathermy is not functioning it is not working, the most common mistake is that to increase the power of the diathermy, because if you are keeping on increasing the power of the diathermy, suddenly it is going to start function, and then you are going to destroy whatever you are trying to do there. Then comes the ligasure. Ligasure basically is a bipolar diathermy, but it has got a computer chip in it. The computer chip, what happens is that the computer chip is sensing the status of the tissue which is held between the two claws or the jaws of the instrument. It has got a console, it has got an hand instrument, and the hand instrument has got a silicone coating in order to reduce the chances of collateral damage, and the advantages or disadvantages can be discussed here. So the effect of a ligasure is a combination of pressure and then energy. The energy is basically electrical energy. So you compress the tissue and then you apply the electrical current, and that leads to sealing of the vessels, the tissue, and the lymphatics, even up to 7 millimeter of diameter. However, it can seal almost all of the lymphatics. It can seal majority of the veins, including the gonadal vein, and in some instance renal vein maybe. However, the artery, you have to be really cautious about it. Artery should not be coagulated and cut. However, small arteries can be coagulated, like for example inferior vesical pedicles, superior vesical pedicles can be securely coagulated and sealed with the ligasure and then divided. So it fuses the collagen and elastin fibers in the tissue, and this coagulation can withstand 3 times the systolic blood pressure of the patient. For example, if it is 120, the systolic blood pressure, so sealing of a vessel by ligasure can withstand 3 times the systolic blood pressure. It has got a very important thing which is called the chip mechanism, and it has got a feedback controlled response. So, and it usually alarms and lets you know that the tissue is completely coagulated, and then you can cut the tissue. So it automatically, you are pressing a button, this button is going to start transferring the energy to the tissue, and once the tissue is completely coagulated and the seal cycle is complete, it is going to automatically give a feedback, and the energy is going to be discontinued, by which you can know that now the tissue is completely coagulated. If the tissue is not completely coagulated, it is going to give you a different kind of alarm. So it is kind of communicating with you, and it is a really useful and intelligent source of energy. The average thermal spread is around the tissue is 2 millimeter. You have to apply an optimal pressure, energy, cycle feedback, and then tissue can be divided with a blade inside it. I personally like this instrument very much. It is atraumatic. By it, you can do a dissection like you can do with the Maryland forceps, and then you can seal, and then you can cut. So it really reduces your operative time tremendously. It's a lovely instrument, ligasure. Here you can see a console and the different hand instruments for use in the open surgery as well as laparoscopic surgery. And we are using this blunt tip laparoscopic sealer divider, which is 37 to 39 centimeter in length. It is 5 millimeter. Then comes the harmonic. What is harmonic? Harmonic is basically an ultrasound machine. So how does it work? It produces vibrations. It converts electrical energy into mechanical energy, and this mechanical energy is basically vibration. So when the two jaws, they vibrate with and in contact with each other, they produce heat. You can rub two hands like we do it in cold during the snowfall or in the winter. When you rub the hands, you feel that heat energy is produced. So this electrical energy is converted to mechanical vibration energy, which is then converted to heat energy. So any energy, any vibration which is more than 18,000 hertz can lead to damage of the tissue in a normal life. However, in surgical field, we call it coagulation and cutting. So, and there is a console, there is a working hand instrument, and the advantages and disadvantages we are going to discuss now. It can seal up to 5 millimeter of tissue and vessels, and nowadays uh, the energy used or the vibration which is used is more than 55,000 kilohertz, 55,000 hertz, sorry. So there are different shapes of the jaws of the harmonic. You can dissect with it, you can coagulate, you can cut with it. The coagulation is achieved by low power, so there will be slower cutting and more coagulation. However, if you are using a high power, then there will be rapid or faster cutting, but the coagulation will be less. No electrocautery is used. This is one of the biggest advantages of the harmonic forceps, and there is lower collateral damage because of that, and there is lower tissue necrosis because of that. However, one thing has to be mentioned. It has got two jaws. One jaw is static, and the other jaw is movable. And the one jaw which is static is actually a metallic jaw, and the other one has a silicone seal over it. So this mechanical jaw or the metallic jaw is actually vibrating to and fro. So anything which touches this jaw is going to get destroyed. So always keep this metallic jaw in your view while using this harmonic forceps. Otherwise, if it is touching, like for example, this is the artery, and you are dissecting something around the artery, but this jaw touches this artery, it is going to just tear this artery. So always keep this vibrating jaw away from the important structures like vessels, like gut, which you do not want to remove from the body. And always keep this vibrating jaw in your view so that you can see what is it is touching. So it is a tremendously beautiful instrument. Okay, we have already discussed the electrical energy is converted to mechanical, that is vibration. Any vibration which is more than 18,000 hertz is going to produce mechanical energy and heat. And the thermal effects may vary, as in all energy sources, on the type of tissue, the amplitude that you are using, high energy or low energy, the time, and the technique. The ultrasonic energy uses three ways. It achieves the desired effects in three ways. Mechanical energy, it actually denatures the protein, then it causes cavitation leading to cell fragments, and then heat energy, which is at the tip and at tissue contact. So these are the three different kinds of mechanisms by which harmonic is working. Then there is another thing. I used it in a center in Bangkok, which is called Thunderbeat. So it is a combination of ultrasonic and bipolar diathermy, or I would say it is a combination of a harmonic and ligasure. It is Thunderbeat, and it's an extremely beautiful instrument. The disadvantages of harmonic, the ligasure, and Thunderbeat is that they are really expensive. Otherwise, there are all advantages. So here is a comparison. You can see the monopolar, then the bipolar, then the laser, then ultrasonic scalper, then the ligasure, and the sizes of the vessels which they are capable of sealing. So in summary, you have to be prepared to work with the basic laparoscopic instruments like monopolar diathermy with a hook, monopolar diathermy with a Caesar, or a bipolar Caesar, or a bipolar forceps. But if you can try the 3D vision and air seal insufflation system and camera holder, they are really very good. Train yourself and your staff the operation theater preparation, the patient positioning, and the instruments to be used. That will be all. I hope you like the lecture, and also like the presentation, and also you must have learned something new about the energy sources used in laparoscopic as well as open surgery. Thank you very much.